As a review for exam number 1, we'll try to solve a set of problems I made 2 years ago. Number 1, describe and plot the level surfaces of the function given in this way. By definition, a level surface is made from this equation, f of x, y, z equal k for some constant k. F of x, y, z is given in this way. So we have x minus y squared minus z squared equal k. We can rearrange it. X equals y squared plus z squared plus k. Now we can see it that surface must be a paraboloid in x direction. So we can plot in this coordinate axis. There's x direction, y direction, and that is z direction. And once k is 0, then we have such a paraboloid. That is k equals 0. Of course, it's passing the origin. And for example, k is minus 1. Then we go over there in minus 1, and we have another paraboloid passing the point there. So there's k is minus 1. In this way, you can plot the level surfaces. Okay. Number 2, determine and verify whether the following functions are continuous at 0, 0 or not. To show if the function is continuous at a point, you have to prove that limit, so that limit xy approaches 0, 0 and f of xy equal f 0, 0. That means limit exists, and the function is defined at the point, and the limit and function value must be the same. From this definition, let's try to check that one. And f at 0, 0 is defined so that the limit should exist, and the limit must be the same as the value 0 in order to be continuous. However, this has no limit, and we consider this one in the classroom. For example, if xy approaches along vertical direction, so x equals 0, then f becomes now 0 over y to the 4. So it is always 0 along the vertical direction, so that if you take a limit, then it is approaching to 0, because it's always 0. But if you choose, for example, x equal y squared along the curve, now xy is approaching, and f becomes x is y squared. So the top is y to the 4, bottom is now y to the 4, so 2 of y to the 4. Along the curve, the value is always half, so that limit must be half. From two different curves, the limits are different, which means that there's no limit. So that from the beginning, there's no limit, so that it must be discontinuous, right? Okay, for this one, Now, for the function, again, we have to check the limit, check if the limit exists, and the same as the value 2. And however, you can easily see the limit must be 0. Now, as x and y approaches 0 and 0, the block x squared plus xy will approach 0, so that the limit xy approaches 0, 0, the g of xy is the same as, now limit here, we try to use a new variable s, then s approaches 0, and s and logarithm s squared. Okay, for that one, it's the same as a limit 2s logarithm s. You learned in calculus 1, the limit of this one is 0, so that we have here limit value 0. And limit exists, however, the limit is different from the function value. So again, this one is discontinuous. Okay. Okay. Number 3, f of xy is given in this way. Explain why f is differentiable at 0 and 6. Okay. Once x is around the 6, in 0 and 6, then that is logarithm is well defined. For every x, this portion is well defined, and also it is differentiable. In fact, we can get partial derivatives. So for part A, we have to show here partial derivatives, f sub x, f sub y exist, and they are continuous. Then by a theorem, the function itself is now differentiable, right? So we have to show f sub x, f sub y exists and continuous. Okay, let's try to get f sub x, and that is minus pi sine pi x, x derivative, and for that one, plus x plus y minus 5 on the bottom, and top is 1. Around the 0 and 6, this is a continuous function. And because it is far away, in fact, at 0, 6, that is now 1, and this is well defined, a continuous function. The same way, f sub y. Now, this portion will be 0, and y derivative will be here 1 over x plus y minus 5. At 0, 6, it's well defined, and around the 0, 6, it is a continuous function. So we checked these two things so that it is differentiable. Okay, now part B. Find the linearization of f at 0, 6. Okay. And that one, by definition, linearization is given in this way. There's f at the point 0, 6, and plus f sub x at the point, and here x minus, now the point is 0, and plus f sub y at 0, 6, and y minus b is 6, right? Okay, here, so we have to get numeric values for these 3 terms, then that's it. What is f 0, 6? Once x is 0, then it's 1. Now 0, 6, that is 6 minus 5. So logarithm 1, which is 0. So that this one is 1. Now we already got f sub x, and by using 0 and 6, that will be 0. And this is 1. So the 1, now x, and plus. How about f sub y? Okay, 0, 6. Then again, there is 1. And now y minus 6. If you want, you can simplify. But this is the answer. Okay? Number 4. Consider the surface. Find the equation of tangent plane to the surface at 2, 3, 4. Okay. For this problem, if you want to get a tangent plane, then already a point is given. But at this point, to decide the tangent plane, you need to get normal vector. And normal vector can be found from the gradient of that portion. For a level surface, the gradient is always normal direction. In fact, the fastest increasing direction. Okay. Now, let's try to get gradient of f. Okay, that is x directional derivative, that is 2x minus 1, and y directional derivative is 4y minus 2, and z directional derivative, that is 6 z minus 3. Now at 2, 3, 4, we try to, okay, 2, 3, 4, we try to get the numeric vector. Okay, x is 2, then there's 1, y is 3, z is 4. So this are all 1. So that we have 2, 4, 6. Okay, that's the normal direction, the gradient. And at 2, 3, 4, we can easily get the equation of tangent plane. So that is 2 and x minus 2 plus 4y minus 3 plus 6 z minus 4 equals 0. That's the equation of the tangent plane. Okay, for the normal line is passing this point. Okay, let's say that is x0, then r is x0 plus t, the normal direction, the direction of the line. That is the vector equation. And if we write down this in detail, r has a 3 component, x, y, z. Okay, and x is 2, 3, 4. Now t times the direction is 2, 4, 6. Right? And from this one, you can get a symmetry equation if you want. And we solve this one for t. Then from the first one, t equal, we move this one to the other side, divide by 2. So x minus 2 over 2. From second one, t is y minus 3 over 4. From the last one, t is z minus 4 divided by 6. So that is the symmetric equation. Okay, number 5. Suppose f is the differential function of xy and GUV is given in this way. use the table of values to find the G sub U 0, 0 and G sub E 0, 0. Let's try to do this one only, then the other one you can do it quite easily. Okay. Now, f is a function of xy. That means that this portion is x and this portion is y. Now, if we want to get G sub v, then by using the chain rule, we have f sub x and x v derivative plus now f sub y and y v derivative. Okay. Now, that is the formula. If you want to get numeric value CV and 0, 0, that means U and V are 0, then f sub x. But the function f is a function of xy, so that you have to put the corresponding value here, not 0, 0. You have to put here x value, y value, when U and V are 0. So for example, now x is given in this way, and once U and V are 0, then x must be 0, 0, x must be 1, and y, okay, that's 0, 0, 0, okay, 0. So that x is 1, y equals 0, right? Okay, x v derivative is minus sine of v, okay, plus, now f sub y, again, that must be xy value, we already know, this is 1, 0, and y v derivative, that is cosine v. Okay, now f sub x 1, 0. So you have to use this value, f sub x at 1, 0, not 0, 0. 1, 0, that is a minus 13 times. Okay, anyway, sine of v is 0. Once uv 0, so that's 0. Plus f sub y 1, 0, which is 15, and cosine v, once v is 0, then it's 1, so that is 15. Okay, for G sub u, you can do it similarly. Z is f of xy, given in this form. Find the differential dz for points xy. Okay. Now dz, the total differential, is same as f sub x dx plus f sub y dy. Right? Okay, what is f sub x? X derivative, which is 1. Okay, that is, this will disappear, and plus 6xy and dx, and plus f sub y minus 2y, okay, y derivative, plus 3x squared dy. That's it for part A. Now for part B, xy changes from 1 to, that is xy, to this one. That means x is moving from 1 to 1.1, so that dx is 0.1, increased by 0.1, and y is reduced by 0.1, so that dy equals minus 0.1. So we know every value, x value, y value, dx, dy. So we use those values to get a numeric value for dz. So dz equal now 1 plus 6 times 1, 2, 6 times 1 times 2, and dx is 0.1, and plus minus 2y minus 4, y is 2, and plus x is 1, so that is 3, and that is minus 0.1. Right? From now on, it is quite easy. And now that is a 13, so 1.23 divided by that 0.1. Now that is minus 1, and now so that the second part will be 0.1. So it is 1.24. Okay? Okay, that's the final answer. Okay, this is the end of the review. Thank you.